Hi, in this video we are going to talk about discriminant of a quadratic. Now why it is called as discriminant? So let us understand that first. So we know that any quadratic equation is of the type ax square plus bx plus c is equal to 0. This is a general form of a quadratic. Now in this, when we write down the formula for roots, that is x, it is x is equal to minus b plus minus b square minus 4ac over 2a. Now in this, it can be clearly visible that b square minus 4ac is inside the square root. So if that term which is inside the square root is negative or positive, it will determine the real nature of x, whether it will be real or it will be imaginary. So what is the main role of discriminant? It will actually discriminate between the type of roots, whether the roots are real or they are imaginary. Now the next thing is, when we say real, so on what basis we are saying that roots are real? So it is quite simple to understand that if the term which is written inside the square root is positive or it is equal to 0, then square root will be fairly defined. Otherwise we know that negative square roots are not defined. So in that case I can say that this b square minus 4ac is the deciding factor, and this thing is called as discriminant. So it should be clear that what is discriminant, why it is called as discriminant, and it is b square minus 4ac. Now coming to the condition. So if the roots are real, then it will be d greater than or equal to 0. In real, it can be either greater than 0, means the square root term can be positive, or it can be equal to 0 also. And if the roots are imaginary, then the value of d will be negative. So if the value of d is negative, game is over at that moment only. Okay, so we cannot solve it further. We can definitely solve it, but then for that we should understand complex numbers. So right now I'm just talking about that how do we determine whether the roots are real or imaginary. If they are imaginary, we can leave it at that form only, and if they are real, we can definitely go ahead and find the values of roots, that is x. Now this condition of d greater than equal to 0 is further divided into d greater than 0 and d equal to 0. Now based on these two conditions, if it is d greater than 0, we can call that roots are real and distinct. The meaning of distinct is that there will be two different values of x which we will be getting. You might have solved quadratic equations, and in that you must have experienced that there can be two different values of x. So this is the case for that. Okay, coming to the next case where it is d equal to 0. So d equal to 0 means if you just make this square root term equal to 0, then the only value of x will be minus b upon 2a. You can look at the term, you will very easily understand that. Okay, so the only value will be minus b upon 2a, means in that case I can say that the quadratic equation have equal roots. So equal roots means they have same value but still they are real. So in real there are two subcategories, one is real and distinct, one is real and equal. They both exist when the value of d is greater than or equal to 0. If it is imaginary, then it will be for d less than 0. So I hope that whatever we discussed, it is clear to you. Likewise, if you need a similar type of video in which you want to learn a concept like this, if you want to revise a concept like this, you can comment it in the comments mentioned below. Thank you.